Hello and hi guys, our group 17 will show you the real life statics example. Before that, our group have 4 members which are me myself Fahmi Nakib, second member Ziyun, third member Fatin and fourth member Sinhui. And each of us have different parts. For me example, Ziyun LO1, Fatin LO2 and Sinhui LO3. For the example of real-life statics, our group had choose Pushing the Wheelbarrow. Hope you guys watch this informative short story. Give us a thumbs up.
During online discussion.
Hi guys.
Hi.
Hello.
Hello. Hi.
By the way, do you guys know how to solve this max tutorial question number 9?
Oh no.
Is it
I
tutorial 9?
haven't done it yet.
Let me see. Let me find.
I think that's the end of our meeting today. Go for a bath and go to eat your dinner. Bye bye.
That evening in Fahmi's house. Wow, it's so beautiful. What is he doing now? He looks so tired. I think he is gardening with his mom. So let's take a look at what he actually did. Stop! Yup, he is pushing a wheelbarrow with brakes on it. And this is also an example of statics in real life.
Calculations.
Okay, so this is one of the photo from Fahmi when he went for gardening. And based on L1, we need to analyze system using free body diagram method. Okay, so as we all know, there's always a normal reaction force acting outward from ground to an object. And based on this photo, we can know that this normal reaction force is acting outward from ground to the wheel, and we can label it as AY. And next, there's an external force exerted in this position, and we can resolve it into horizontal force and vertical force. However, for this horizontal force, it doesn't matter must be in the left or in the right position, or same go for this vertical force doesn't matter must be in the upward or downward position. When we get negative sign from the calculation, we can know that the actual force directed is in opposite direction from the free body diagram that we draw. Okay, so why we label it as 2by and 2bx? This is because since both hands are involving in exerting the forces, we assume that the magnitude of force for each side is same. Okay, and last is the weight. Okay, so the direction of the total weight from the brick and the body of wheelbarrow is directed downward is due to gravity. And from the calculation, that the weight of one brick is 2.7 kg and it consists of 15. So we multiply it by 15, and the weight for the body of wheelbarrow is 3.25 kg, and we total up. However, this unit is in kg, and in order to get the answer in Newton unit, we need to multiply it by 9.81. And finally, we will get the answer is 429.1875 Newton. Okay, so we also can draw the free body diagram in a simple way as shown at here. 2by, 2bx, w, and ay.
For NO2, we need to use equilibrium-based analysis for various structures. And from here, we can see that there are few forces acting on the wheelbarrow, which are AY, W, BX, and also BY. So this is the calculations. For the calculation, the first step is we need to draw the free body diagram, and after that, to determine the value of AY, we need to solve for the sum of the moments of all forces about point B, which are force moment of W plus with moment of AY. So before we proceed with the calculations, don't forget to convert all of the distance into meter. So after that, to calculate the sum of moments we take the value of W times with its perpendicular distance, which is 0.767 minus with AY times with its perpendicular distance, which is 0.327 plus 0.767, and from that we got the value of AY is equal to 289.0139 Newton. So from here we can see that the moment of W is positive while moment of AY is negative. So this is because moment of W is acting anti-clockwise, so that's why the moment is positive, while the moment of AY is acting clockwise, that will result in negative moments. So after that, we need to determine the reaction at B by solving for the equation for the sum of all horizontal forces and vertical forces. So for the vertical forces, which is Fy, so the equation is Ay minus W plus 2By, and from that the value of By is equal to 70.0869 Newton. So since both hands are involved in exerting forces on the wheelbarrow, so we will assume the magnitude of the force is equal for each side. So that's why the By is multiplied by 2. So for the horizontal force Fx, we can see that only Bx is acting on the horizontal side. So from that, we know that value of Bx is equal to 0. And lastly, to determine the value of force at point B, so we substitute the value of Bx and By into the formula and get the value of Fb is equal to 70.0868 Newton.
Let us move on to our LO3, which is to choose one component from our example today and analyze it using the principle of moment of inertia. So the component we choose for our example today is the body of the wheelbarrow. So here are some pictures of our team member measuring the dimension of the wheelbarrow. And now we put the axis as shown in this picture. So the x-axis and y-axis are plotted as shown. And now we want to calculate the moment of inertia about x-axis, which means that we want to calculate the moment of inertia with respect to x. So now we split it into three components here. So first is a triangle, and second is a rectangle, and finally there's another triangle here. So to calculate the moment of inertia with respect to x in triangle 1, we use this formula, 1 over 12 bh cubed. So with the dimension of 29.1 cm and 21.8 cm here, we substitute in the value and we get this answer. And next, we follow by the rectangle with the dimension of 33.5 cm and 21.8 cm. So now we use the formula Ix equals to 1 over 3 bh cubed. And we substitute in the values and we get this answer. And finally, we continue with the last triangle. Same thing, we use the formula 1 over 12 bh cubed. And we substitute in the dimension 15.2 cm for the base and 21.8 cm for the height. And we could get this answer. And next, to calculate the total Ix, which is the total moment of inertia with respect to x, we need to add them all and we could obtain this answer. And finally, to calculate the radius of gyration. So we are given this formula kx equals to square root of Ix over a. So Ix is the total moment of inertia with respect to x, and A is the total area for the components. So we substitute in the values and finally we could get 0.11 meter for our radius of gyration. That's all from us. Thank you.
Thanks for watching.
Thank you.
Thank you for watching.